not give you the full details, there is a very interesting result there. That a stock price, you can price an option in this new hedged setup. So initially we priced our option just as a lottery, right? As a lottery which, so that the option underwriter wouldn't have any way to control their risks. But now they do have a way to control the risks. And it appeared that you don't need to hold just one stock per each option underwritten. In general, you need less than one stock per each option. Why less? Because, for example, let me show again this hockey stick to you, okay? Okay, that's our hockey stick. That's our payoff. That's ST. Strike K. Now, suppose that initially the underlying price is somewhere here, in this region, okay? It can get beyond K with some probability because it is a stochastic process, it can. But at the moment it is here. If it is here, then there is quite a low risk that you need to pay anything at all. Because obviously if it ends up, so at time t capital, for example, it stops here, it moves. S moves back and forth before the time t capital. If it stops, for example, here, then you don't need to pay anything. It is only if it overshoots K, then you need to pay something. So if it is here, you don't need to worry much. What you may do is just for a relatively small probability that the stock price moves above K, you would, for example, you have issued, let's say, 100 options to different clients. And for all of them, you would have just maybe a few units of stock to hedge your position, so that if with low probability the stock price really moves above K, you would be able to pay the difference. But on the other hand, if your stock price is already in that area, then there is very likely that by time t capital it would stop somewhere in that area. In that case, you probably need almost, maybe still less, but almost one stop per each option you provided in order to guarantee that you will be able to pay the difference. And that's the hedging. It is so-called delta hedging. So you actually, instead of just holding a short position in the option, you hold a position in the option and some quantity called delta, typically delta less than 1 per option, units of stock to provide funds to pay the payoff. This is called delta hedging. Delta hedging is very fundamental to managing options in the modern environment. I will not give you, or it's probably going to be too much detail, all constructions of how we construct the delta hedge and parity options and so on. We just arrive at a very surprising result, that under delta hedging, very similar formula to option prices exist, with one exception. Instead of, you remember what was alpha here? Alpha was the growth rate for our stock. It was the trend of our stock in geometric Brownian motion. So, if the option underwriter delta hedges his options, alpha becomes absolutely irrelevant. That's a strange, counterintuitive, paradoxical, but nevertheless mathematically and practically established fact. If the option underwriter provides delta hedging, then it doesn't matter whether the underlying stock is growing and it is very likely to end up here, where the payoff is really payable, or it is declining and it is very likely to end up here, where there is no payoff. No matter at all. Strange, isn't it? For the underwriter, and actually for the underwriter in particular, it doesn't matter at all. Instead of alpha, we use exactly same formula for option pricing, so it is exactly the same probability density function, PT of x. It is exactly the same formula here for a call. Apart from one thing, in a hedged environment, our alpha is replaced by something. Actually, alpha occurs only in one place here. You see, beta occurs many times. Beta is here, beta is here, beta is here, right? Alpha is in one place only, as you can see. In a delta hedged, in a hedged environment, alpha becomes totally irrelevant, and it is replaced by one quantity. So I would like to ask you to guess by which quantity alpha is replaced. We have seen it so many times today already, just name it. Which letters did we use? Alpha is a growth rate, it is a relative growth rate. So what is another quantity of the same dimensionality, which is a growth rate of something? Beta is a volatility. Something which we used as recently as 10 minutes back. Actually, yes, so that's not the price. We must also apply the discount factor, which I deleted, right? Then the discount factor. So what is the quantity to replace alpha with? It is the risk-free interest rate. Interestingly enough, so instead of alpha, we use R here. Which means that in a hedged environment, it is like all our financial contracts and portfolios, they would grow, if completely hedged, with the same rate. Same rate as a risk-free interest rate. And from this we immediately obtain, when we take this integral, we obtain the Black-Scholes-Merton option pricing formulas. I'm not going to give these formulas to you, because I believe that you are already tired from our previous discussion. At least, I don't see much enthusiasm for continuing with hard mathematics. Let's just see a more practical example, which we started with. So, if I expect that, let's say, the stock price will grow, what should I do? Buy the stock itself, hold it and realize the profit, or buy an option? Let's do a very numerical exercise of that kind. Okay, suppose that now at t equal to 0, x0 is $100. I expect, how do I expect? By technical analysis, by alchemy, by magic ball, I am told by my consultant, I meditated, I expect that at time t equals to t capital, which is 1 year, xt will be $120 at least. Okay?
Что такое X? То есть,
X is our stock price. That's what we started with. It is the stock price. Okay? Now, which means that if I'm correct on that point, in 1 year, and I buy a stock, I will make a profit which is equal to, in relative terms, it is $20 per stock, which means 20%, because I need to buy the stock first. Okay? So that should be clear for everyone. 20% profit, right? 20% profit. Good point. Not bad. But now, let's do another tactics. Instead of just buying a stock, I buy a call option with the strike also $100, as now. It is so-called at the money option. So that's first thing. Buy and hold a stock. Okay, buy and hold stock. Our second choice is to buy the option buy option. Let's say strike K is same $100. It is quite typical. How much would I pay for this option? So the price is given by this integral. Obviously, we don't have any computational tools to evaluate this integral. It depends on, actually, this log. When we evaluate this, it would become the ratio of K to X0, but nevertheless, it's quite difficult to evaluate it. C, the price which we pay, this is 0. Let's see, it depends on, first of all, time to expiration, this 1 year. It depends on the risk-free interest rate R. It doesn't depend on the growth rate, actually, as we know. It depends on the volatility beta. So very roughly, under, let's say, normal parameters for a stock, let me say that for 1 year, this C0 would be, let's say, $10. That's more or less a correct figure. So suppose that it is $10. The exact value can be obtained using these formulas, but we are not going to evaluate them precisely now. Just believe me that it is going to be around 10. Okay? What does it mean? It means that buying an option is by far a cheaper thing than buying the stock. You don't need to invest $100, right? You only invest $10 per option. Okay. Now suppose that your magic ball appeared to be correct, and your stock price after 1 year was indeed $120. Which profit do you get in this case? You receive the payoff, which is ST minus K. Your strike was 100. ST was, XT. XT was 120. So you receive the payoff equal to $20, right? In this case, $20. But you need to subtract from this the initial price multiplied by the anti-discount factor. Okay? Suppose that R is very small, let's say 0.001, therefore you would still have this anti-discount factor pretty small. So your net profit is approximately equal to $20 minus $10, so it is $10. So in that case, you made a profit of $10. In the first case, you made a profit of $20, right? Here only 10, because you had to pay the option premium. But these $10 are only per 1 per $10 of your investment. You didn't invest 100. You invested 10 into the option and made a profit of 10. So your profit rate is 100% in this case. So by using options instead of the stock, you leveraged your return 5 times, from 20% to 100%. Good, isn't it? Now, can you tell me please, so what is the drawback of this approach? You know what, if the options are so cheap, let's do the following. Let's go to Sberbank. Is there a Sberbank in Annapolis? I didn't see. Yes, okay. I mean, not a cash machine, but really a bank.
Yes.
Ah, there is one, okay. Apply for a loan of 1 million rubles, okay? Spend this whole loan on buying cheap options, $10 each. What a good idea. And then we'll make a 100% of return, so we'll get, you know what, 10 million rubles after a year. What do you think about this idea? Why not?
It's not reliable.
We implied here that we will have a price of $120, but
Precisely.
it's not guaranteed.
It is not guaranteed, and if it is not there and your options expire out of money, you are in a much worse position than it would be for just investing into stock itself. So now suppose there is a pessimistic situation. Okay, so that's optimistic, okay? That's an optimistic one. Now suppose there is a pessimistic situation. And not even so pessimistic. Suppose that the price just remained at 100. Didn't move, eventually. The price remained at 100. What would be? In the first case, when you invest into stock itself, you make 0 profit. No profit, no loss. So 0 profit. Not good, but not terrible. But in this situation, you simply completely lose all your premium paid into the option. Right? So you lose your $10. Is it much? $10 probably not. But if you borrowed 1 million rubles and put all this 1 million rubles into those cheap options, buying a large number of them, then your full investment is evaporated completely. So in that case, pessimistic case, not so pessimistic, XT is still 100. Then in case 1, your return is 0, but in case 2, your return is minus 100%. So basically it means that you completely destroy all your investment. That's why options are much riskier. So you can get a leveraged return, but you can get a leveraged loss as well. When buying an equity, a stock, unless there is a very unpleasant situation, so for example, the company completely goes out of business, bankrupt, and your stock is delisted, so it is no longer traded at the exchange, then it would still be worth something. The stock price wouldn't go to 0. You can lose 5%, you can lose 10%, you can lose 50%, maybe 80%, but still not 100%. With options, it is very, very, very likely that you would lose full 100% of your investment. Full 100%. And this is just a relatively innocent example with let's say, our call option. You can construct much more sophisticated options. There are binary options, which all those people ask you on the internet to buy. There are even worse, I would say, barrier options. Just to give you an idea, you will like this idea, actually. To give you an idea what the barrier option is, it is the following. let's do this two-dimensional plot. That's time. We start at t equal to 0. That's our option expiration time t capital. Let's say 1 year, okay? That's x0, where we started. There is an option strike, k, somewhere here as well, which can be either x0 or slightly less or slightly above, doesn't matter, okay? But suppose that this x0 is $100, your option price. Sorry, your stock price initially. You also put barriers. So you put one barrier below the price, let's say at 80, and one barrier above, let's say at 150, something like that. And then that's the path of your stock price from t equal to 0 to 1 year, okay? Now what? If your path is entirely confined between the barriers, then all is fine, and when 1 year elapses and your stock price arrives here, then the normal rules, as we discussed for the call option, they would apply. So then you would receive a payoff of this xt minus k plus. Okay? In a similar way as it was before. But if somehow your path touches upon a barrier either going down or above, so below the low barrier or above the high barrier, then your option is annihilated immediately. It is so-called knockout. So this barrier option is called double knockout. You can be knocked out if the price even briefly goes below the low barrier, or if the price even briefly goes above the high barrier. Not here, but any way along the path, even for 1 day, even just a brief touch. Then the option is immediately, I wouldn't just say expires out of money, it just didn't expire, it is knocked out. And obviously, the options which are subject to this knockout are even much cheaper than our call options, standard call options. So compared with these reasonably placed barriers, compared to our classical call, the option price could be less than $1 in this case, so that's $1. Extremely cheap option. So it is even more, I would say, incentive to borrow 1 million rubles and buy all those extremely cheap options, because you know, if the option price is only $1, then you have not 100%, but 1000% return if all goes to the plan. Unfortunately, the probability distribution will be the following in this case. You can, from similar formulas, you can construct it in very, I would say, careful detail. With the probability of 95%, you are knocked out or you expire out of money. So one way or another, you lose all your investments. With a probability of 95%. With the remaining 5%, let's say 2.5% allows you simply to recover your costs. But with the probability of, let's say, 2% something, you can make huge return, really, let's say between 500 and 1000%. So, yeah, there is a chance for a huge return, but highly asymmetrical distribution of returns and a huge probability to completely vanquish all your investment. That's what means actually about investment with options. Good idea or not? Well, in this simple setup, not. But in general, options do allow you to construct portfolios which are balanced any way you like between ultimately high risk and ultimately high returns, or possibly no risk and low returns, maybe even having less risk as the original stock. So options are great instruments for financial engineering. You can tailor them by constructing, for example, different barriers, different strikes, different hedging policies. You may hedge or not hedge your option, or have partial hedges and so on. Then you can construct a large variety of financial instruments. That is what financial engineering is called. Or there is another term which is roughly equivalent to financial engineering. It is called structuring. So there is a profession, financial profession, which is called structurer. It is someone who constructs sophisticated portfolios consisting of options and underlying instruments in order to achieve precisely the desired profile between risk and returns. And actually, let's play a game to conclude this lecture. Let's play a game on taking financial risks. So, let's do the following. I have $1 million. So I will do the following. To any one of you, I will give $1 million for 1 year. Not for free, for some price. See. You do whatever you want with this $1 million within a year, okay? But you pay me this management fee upfront, and by the end of the year, you must return $1 million to me. If you didn't return $1 million to me by the end of the year, you go to prison for 5 years. So the question is, how to calculate how much you would pay, you would be willing to pay this initial fee to me, just for the release of $1 million to you.
It depends on the instruments that you're going to use.
It's up to you. I give you $1 million. Do whatever you want. Invest them into stocks, invest them into options, invest them into cryptocurrencies. It's completely up to you. But you need to pay me this initial fee just for the release of $1 million. How much? That's the question, how much? And return $1 million by the end. The rest is completely up to you.
Oh, and we need to calculate the fee we are willing to pay.
Yes. Calculate the fees you are willing to pay based on whatever criteria would be suitable.
Half of the interest rate of the половина процентной ставки по этим инвестициям.
You know what, you are right.
Да.
You are generally right. So first of all, a wrong way to solve this problem, a wrong way, which doesn't have the concept of hedging into account. Actually, this question was asked to me at the very final stage of my interview to Goldman Sachs, when I already passed all these mathematical tests, and there was a final acceptance interview with a managing partner. So she asked me this question, although it was already generally decided that they would accept me, but just to show that, it's not just sufficient to be a mathematician or a computer scientist. You really need to learn to think in financial terms in order to work for the financial industry. So my approach, how I would start answering this, would be based on the utility function approach, and the expected value, unhedged expected value, very much like we started with. So I would say, okay, I earn that amount per year, let's say. If I get into prison for 5 years, I would lose that much of income, plus interest rates. That's what I realized. Plus some moral damages for being in prison and being my career torpedoed after that. Because obviously someone with a criminal conviction wouldn't be eligible for working in the investment bank. So I estimate that the total amount of damages which can occur to me if that happens, okay? Then I would, given my investment strategy, I would calculate the probability of not returning $1 million Let's say this probability is 5%. Then I would multiply this all loss function, loss amount, okay, by this percentage, and that's how much I am going to charge in order to probabilistically recover my costs. A utility function based approach. Valid one? Probably yes, but not the best one, because there is a much better approach actually, which the gentleman actually pointed out. So what the better approach is? Okay. I think by now everyone understands what the better approach is. The better approach, use hedging in a way similar as we discussed, and eliminate any risk of going to prison whatsoever. With delta hedging, as we discussed for option pricing briefly, the option underwriter never faces any risks. So he is always guaranteed that he would be able to repay the payable function to the client, no matter how much the underlying would grow. A similar situation here. So listen, we got this 1 million. We know that we start with 1 million under the risk-free interest rate, which is guaranteed. In a year, 1 million would become, very roughly speaking, well, okay, it is exponent of R times 1 year times 1 million, okay? With our continuously compounded interest rate. Therefore, if we start with a lesser amount, so exponent of minus R times 1 million, then it would become exactly 1 million at that, okay? So, take this amount, put it into a risk-free instrument, which is either a 100% reliable bank account, or into the US Treasuries, which are, you remember we were discussing these interest rate instruments. So government bonds, like US Treasuries, are also risk-free. Put them into that instrument. In that case, you would be guaranteed to return 1 million. And the rest, which is 1 minus exponent of minus R times 1 million, which is approximately equal to, not exactly, but approximately equal to just R times 1 million, is free for you. Then yes, you can pay up to this amount for the right to manage 1 million, so that's the maximum you would be prepared to pay. And the rest you can invest in whatever scheme, even buying these barrier options with the possibility of a huge return, and that's okay. So that's how, that's the correct way of solving this problem. And that's how the structures actually work. A client comes and he says, I would like to, there is no magic, but he says, I would like to get a risk-free return and at the same time higher return than the risk-free interest rate. Both. We say to him, well, we probably can't do that, but what we can do? We can guarantee to you, for example, 95% of your capital intact, 95% principal. So we really remove 5% or so of his capital, put the rest into a low income but still 100% reliable account, either bank account or government bonds or something like that. But for the rest, we do highly risky, highly speculative investment into instruments like options. That's precisely how structuring works in investment bank. That's all. Thank you.